Uh, Hello, am I audible?
Yes, sir.
Okay. Good evening, everyone. Uh, so we will wait for 5 more minutes to other student can join. Thank you. Hello. I think we can start now. So first we will discuss about the magnetic disk, and after that we take this doubt from the practice question, and then we will take some SQL question on the peer deck. Am I audible?
Yes, sir.
Yes, sir.
Okay, let me share my screen. Is it visible, right?
Yes, sir.
Okay. So in that today we will nowadays what we use for the storage system as the magnetic disk, because it is cheaper than the cheaper storage form, and uh, we get the we can store the large amount of the data and the cost saving. So it is the low cost form of storage form, right? So in the magnetic disk, it consists of the 1 to 5 platter, right? Magnetic disk and so consists of the platter, right? And it is mounted on the spindle. So this particular thing is called the spindle, and these are called the platter, right? And the platter have the surface, on the surface the magnetic material are there, where which is used for the storing the information, right? So in the both surface, if in question it is not given the which unless explicitly given that the one surface is used, otherwise by default you have to use the both surfaces used, right? Is it clear, right? Hello.
Yes.
Yeah, by default you have to assume the both surfaces are used, right? So let's take the okay, one platter, right? This is the top view. This platter is divided into the track, right? Like this. So these are called the tracker, right? Right. And the track are divided into sector. These are all logically, right? This is called the sector, right? And the for the read write purpose, this is a one arm assembly are there. This is called the arm assembly. Right. And this particular thing is called arm. And here it has the read write head. Right. So up to this is clear to everyone. Yeah. Any question?
Sir, one doubt.
Yeah.
Sir, this is sector or geometrical sector? Because we have two sectors, one geometrical sector and one is a track
No.
sector.
Yeah, this particular thing is in this. I'm what we have discussed about this particular thing. So this is one sector, right?
This is a which sector, geometrical sector or track sector?
No, no. Here I am using this particular thing as not confused with the geometric sector, right? So if I call the sector, then you assume I am talking about this particular thing. This is one sector.
Sir, then if it is a sector, then it is one of the two. Either it is a geometrical or track sector. So which sector it is? It is geometrical sector or track sector?
It's track sector.
Yeah, that's my doubt.
So it is track sector.
Okay.
So suppose you have the platter, right? And the number of platter is P. And suppose you have given like this. Numbers of the platter as the P and then breadth per surface is equal to T, right? And yes. So how to find the total numbers of the sector in this particular? So can you tell what is the total numbers of the platter? Anyone? Total numbers of the that is P given, right? This is the total numbers of the platter. This is the one platter, and so this is one. This in this type, P platter is given, right? Here I have written here the platter equal to P and the tracks. Is it visible, right?
Yes, sir.
Yes, Pradeep, visible.
So total numbers of the platters. Platters equal to P, right? And the total numbers of surface equal to, can anyone?
10 surface.
10. No, assume
2P.
that P,
2P.
2 into P. Because I said that the by default we are using both surfaces, right? In the platter. So total numbers of tracks equal to
Into T, 2P into T.
2P into T, right?
Yes.
And the total numbers of sectors equal to
Yeah, 2P into track into sector.
T into S, right? And if you have given the sector size, suppose it is given as the 512 bytes, right? So can you tell what is the size of that disk? Yeah, you have given the total numbers of the sector is this is. So that is 2PTS, and the one sector size is 512, right? 512 bytes, right? So you have to multiply with the total numbers of sector. You find the total size of the disk. Am I clear to this point?
Yeah, but T is still.
Yeah, this is the total numbers of sector. Yeah. Suppose assume this particular P equal to 5, right? So Let's
Yeah,
take
P equal to, it depends, right? 1 to 5.
yeah.
Yes.
Just as
yeah.
yeah.
Okay.
Just assume this is right. It is clear to assume. So total numbers of platter is sector is 2 into P is 5 and T is 20 and
Into 5 and 12.
and 12, and that is 4 double zero, right? And so you have to multiply with this particular size of one sector, that is 24051 up to this is clear to everyone. So this is the size of disk. Any doubt how to find the size of disk? Yes or no?
Yeah, for B it is yes. Unclear.
So let's proceed. And one thing that you see this particular arm. So here you can see in the this is the each sector and this read write head at the same time it is a position to the same sector. If it is ith track, means if it is in the ith track, the same read write or second is also in the same ith track also. So you can assume this particular thing as the cylinder, right? Logically. Is it clear to everyone? So we can say that the numbers of track equal to numbers of cylinder. Right? Because here you can see, suppose there are 3 tracks. So numbers of cylinder is also 3. Yeah. It is clear this point. What is the numbers of cylinder? Numbers of tracks equal to numbers of cylinder. Yes or no? And one thing before we proceed forward, I would like to know from your side, you are aware of this particular thing or not? Can anyone tell what is the in 1 byte? How many bits?
8 bit.
8 bits, right? Okay. And one in 1 KB, how many bytes?
1024.
Oh, 1024 or 2 to the power 10, right? The third is 1 MB equal to how many KB? Then 1024 KB. Yeah, yeah. Who's, yeah, you can tell. Or 2 to the power 20 byte. We can say that. And the 1 GB equal to 1024 MB or 2 to the power 20 KB, right? Yeah, up to this is clear.
Yes, sir.
Yeah, And one thing, everyone know about that math floor function and the ceiling function, right?
Yes, sir.
So can you tell what is the floor value of this particular one?
2.
2.
2. And what is the ceiling value of
3.
3.
4.
3.5?
Oh,
4.
4.
4.
So,
Okay. Thank you. So now we come to the magnetic disk performance measure. So for that we calculate the access time, and the access time is, the definition wise, it is the time to read or write request issue to start the data transfer, right? And what is the seek time? Seek time is the time to reposition the arm over the correct track, and the rotational latency is time for sector to be accessed to be appeared under the head. So let's see what is that. So this is the platter, and suppose this is track, right? This is the spindle, and suppose this is the arm, or this is read write head. This is arm, and this is the read write head, right? So suppose we want to read the data from this particular sector. So for that we have to move this read write head to here, right? And one thing, this read write head is move only forward and the backward only, and this particular thing are rotate on the spindle, right? So for that, this to reposition means to come to the correct position of that track, and this particular time taken, this is known as the seek time, right? So it is clear to everyone. So seek time, what is seek time?
Sir, is that the time required to reach the track?
Yeah, correct track. Yeah. So it has to be moved from here to here, right? So that time is known as the seek time, right? And for the average case, we will take the half of the both case seek time. So that is, if this is the outermost and this is the innermost, so we take for the average seek time, that is half of the this total seek time from here to here, right? So we will deal with the average seek time. Seek time is clear to everyone, right? Yes or no?
Yes, sir.
And what is the, I said that this particular platerism moving on some spindle, right? So for that, suppose your sector is here. So this particular, this arm is not moving. So this plater is moving like this. So if have to be come under this read write head, so this time taken to reach here is known as the rotational latency, right? So I think these two terms are clear to everyone. And for the rotational latency, we takes the average. Average means half of the total time of the full. So time taken to complete one rotation. We take the half of that as the rotational latency. So, one rotation. So these two terms are clear to everyone, right? And so a rotational seek time plus rotational time plus data transfer time, these three are together, three are called the access time of this particular uh, access time, right? So I think it is clear to everyone what is access time, what is seek time, and what is rotational latency, and what is the data transfer time. Can anyone tell?
Sir, access time include data transfer rate also.
Yeah, it will include this particular, but if in question it is not given, then we neglect this, ignore this thing.
Because in the slide, under the heading of access time, only seek time and rotational time are mentioned, not the data transfer rate.
Yeah. So you, if in question it is not given, you can omit that part. This is very uh, so it may okay. So can anyone explain what is the peak time and what is rotational latency and what is access time? Fine. So everyone solved the practice question, right? Yes or no? Those who have solved, can you raise your hand? Am I audible, right?
Yes, sir.
So how to solve this particular question? Anyone would like to explain or volunteer?
Hello, I can.
Yeah. Tell me.
Okay. Here it is given that 10 platters. So total surface will be 20.
Okay. Let me write. 10 platter is given.
So total surface will be 20.
Total surface.
And it has 64 tracks. So total number of tracks will be 20 into 64.
Equal to 20 into 64.
64.
Yeah.
And total number of sectors will be 20 into 64 into 256. Now the second part is coming. It is given that 4 bytes are resolved. So the total resolved will be 20 into 64 into 256 into 4.
Total space reserved.
Yes.
Total space reserved for system.
With 20 into 64 into 256 into 4. These are all in bytes only right now.
Yeah. Yeah. Into 4 in bytes.
Correct. And total disk size
Total disk size
is 20 into 64 into 256 into 512.
20 into 64 into 256
into
and
512 bytes. And the disk size which is for available, when we subtract this from the total disk size minus the reserve size, we will get the available size to be
available
used.
space. Yeah.
Correct. And now you
So,
can convert that into divided by 2 to the power 20 so that we can get in MB.
yeah, available space is total disk space
Minus reserve.
reserve. And that is first we convert this particular anyone have calculated this particular in MB? What is
Let me
Yes, Pradeep. Approximately total disk space is 160 MB.
sir, this one particular total space reserve
Total space reserve is 1.25.
1.25 MB, right? And this is
160 MB.
160. And so we get 160 MB minus 1.5 MB. That is 158.75 MB, right? So anyone face problem to solve this particular this question? Everyone have understood. If you have any problem, you can ask. No problem. So here you can see this is for the second 13 problem, how many numbers of bits is required to addressing all the sector. So this is the total numbers of sector, right? 20 into 64 into 256, right? So can anyone explain how to solve this question?
Can I?
Yeah.
Yeah, the total sector to be addressed, it is log base 2, and the whatever value is 20 into 64 into 256 will be coming.
We get for the question 2, that is the log 2, right?
Yeah,
And
into
that
the
is
total sector.
20, 64 into 256, right?
Which is
And
rough,
we take the ceiling value, right?
exactly, which is roughly coming around to be 19, I think so.
So that is ceiling value, right? That is ceiling. Yeah. Everyone got this particular thing why 2 bit is required. Means log 2, why we are using log this. Anyone have any problem?
Yes, sir. I don't get it.
Otherwise, we have to divide by 2 till we get
Yeah.
a number. So that number.
You not get it, this thing. Yeah.
It is coming approximately 18 point something, which is round figure to be 19. Round figure is 19
Okay,
because the
okay.
address is always in number.
Yeah, integer. Yeah. Who unable to understand this?
Sir, can you explain, sir? I'm unable to understand, sir.
Okay. So there are two numbers, suppose 0 and 1. So to represent this particular number, you have required only one bit, right? This is the one bit. So 0 and the 1, you can replace here. This 0 and the 1 for the 4 number, right? 0, 1, 2, 3, 4, right? So you can write like this 0, 1, 0, 1, 0 in the binary, right?
Yes, sir.
Yeah. So you can see the formula for the 2 number is log 2, 2. That is 1. That is the 1 bit is required here.
Mm,
And here you can see the log 2, 4. That is 2. Right? 2 bit is required. Similar way, the total numbers is, this is the total number. And so we are using the log 2. You can replace this with this one. So that is 20, 64, that 256. Right?
okay. Okay, sir. Thank you, sir. I understood now. Thank you, sir. Thank you, sir.
So the second question is also from the practice question. Anyone have solved this question? Anyone? You can try at least. So what is the previous problems is guided by who? Can you tell your name? Previous problems, this particular. So
Can
here
I,
you
sir?
can, yeah.
Okay. In this question, it is given that the rotational that is 30,000 RPM.
Yeah, this is
That
the
is
rotation.
the total
Rotation.
time. Yeah, it is given 30,000.
A rotational speed.
Yeah. And which means to rotate one times, we have to divide because 30,000 takes in 60 seconds.
Yeah.
So one rotation will be 60 by 30,000, which is
We have to find the time required for one rotation.
correct, sir. Correct, sir. For
For
one rotation, how many times it's taking? It is coming to be 0.002, which is 2 milliseconds.
Yeah, that is, let me write. This is the minute, right? So we have to make it in second, and this is 30. So over here you can see 2, and that is 2 millisecond, right?
Correct, sir.
Yeah.
And
So
the capacity of one track, it has given 200 sectors, and each sector has 5.2 bytes. So the total number of bytes will be 200 into 5.2.
So total size of a track, yeah.
Will be 200 into 5.2.
Let me write the formula also. So that is the sectors into sector size, right? And that is
That will
200.
be coming 102400.
1024
200 into 5.2.
Yeah, bytes.
Yeah. Now we can calculate the transfer rate. This is the total size divided by the time required for one, that is 2 milliseconds.
Data transfer rate, right?
Yeah, transfer rate, data transfer rate.
And the formula is total sector size.
Total size by for one
track
rotation.
size. Yeah, track size. Right. That is track size. We calculate here total size of track.
And that's our answer. That will be coming in bytes by some milliseconds. Now we can convert by dividing 1024. Exactly. That will be 102400 divided by 2.
Total size of track divided by
Ah.
time required for one rotation.
One rotation.
And that is 102400
Divided by
bytes
2 milliseconds.
by 2 milliseconds. Right?
Yeah. That will be 5.200.
And here you can see that is given in kb, so we have to convert this particular one as the kb. For that we have
For
to
that we
divide
have
it.
to 1024. Correct, sir.
Yes, so here we can get answer.
50 kb per milliseconds.
50 kb per millisecond. Everyone got this question, right? Clear to everyone? Solution of. You have to remember this particular formula. What is the data rate? Transfer rate, right? The formula is the total size of track and the time required for one rotation to complete the one track. I hope everyone got it. Please try at least. And what is the approach for the next question? Yep. What is your name? Anyone would like to guide me? Okay, no problem. So here you can see the given is the file size, right? File size is KB, right? And in question you can see the seek time. Seek time is uh, so let's please solve everyone. So we will wait for 5 minutes. After that, after then we will discuss about this particular question. Let's try. Uh, yeah. You can paste your answer in the chat. Yeah. So let me write what is given to you. Yeah, submit got the 8.02. So we will wait for 2 more minutes, after then we will discuss about that. I think we can discuss now. Sabit, can you explain?
Yes, sir.
Yeah.
And in this question, seek time is giving 3 milliseconds,
Yeah.
and the data files are randomly stored. So for this, we have to calculate the rotational latency first. And in the from the previous question, it is half of the time required for one rotation.
We have to find the rotational latency, right?
Yeah, correct. Rotational latency will be 1 milliseconds.
Rotational latency. So that is the average of the
For one
total
track.
time. Yeah, to complete
Half
one.
of time required for one track.
Yeah, and so the time is the 2 millisecond. We already calculated.
Correct, sir. So the
Yeah, and that is 1 millisecond. Yeah, go ahead.
so total time required for checking each file, as the file is randomly selected. So total time will be 3 milliseconds for 1 millisecond, which will be 4 milliseconds.
For the one access of the one sector is the
4 milliseconds.
one sector is
For each sector, we need 4 milliseconds.
yeah. That is the seek time is the 3 and the 1 is the rotational latency, right?
Correct, sir.
So that is 4 milliseconds. That yeah.
And now the number of sector where we have to store the files will be, it is given as 100 kb, 1000 kb, 1000 into 1024 divided by 5.2.
Yeah, this is the total size, file size. So
Number
we
of
have
sectors.
to, yeah, we have to find the numbers of sector, right?
Correct, sir.
So that is, if we divided this total file size by the one sector size, then
Correct.
we will get it.
Get the number of sectors, which is giving 1000 kb, so 1000 into 1024 divided by 5.2, which is coming 2000.
2000, right?
And total time will be 2000 into 4 milliseconds, which is coming to be 800 milliseconds.
So total access time for the all sector, right?
Correct, sir. Total.
Total access time.
Or we called it as total time required for placing the heads on each sector.
Yeah. Each sector. That is 2000 into 4. That is 8000
8,000 milliseconds.
millisecond. We can say 8 seconds.
Yes, sir. Now we have to calculate the transfer time. Is the total file size divided by the transfer rate.
So now we have to find the transfer time. Yeah.
Data transfer time. That is
That is
file size by transfer rate.
file size by the data transfer rate. Right?
Yes, sir. Which we have calculated previously. That is 1000 into 1024 divided by 5.200.
Yeah, we calculate right the 5 kb, right?
Correct, sir. Which is approximately something for me it is coming 20 and for you 0.02. I think so.
I also get the 20. This is milliseconds, right?
That is milliseconds.
Yeah, I guess
20.
the 20 milliseconds. So
now we have to add this to we get the answer.
that is 8 seconds plus 20 milliseconds, right? Second option is the correct option. Hello. Everyone got this magnetic disk, what is the magnetic disk concept, peak time and the rotational latency. Please go through once this every example we solve. Any other question from the practice session or any doubt regarding slide activity question? Young Neeraj, yes sir means you got it or not?
Yes, sir. Yeah, okay. Any other question from in practice assignment? We have got question number 2, 3, 12, and 13. Any other doubt? So there is one question based on buffer replacement policy on LRU. Anyone face any issue in that question? So everyone has taken the PDSA course, right?
That I didn't understand, sir.
Now, in question number 14 from practice
14.
assignment,
Yeah.
one
No,
question
no.
is based on buffer replacement policy, LRU algorithm.
Yeah,
No, I
that is
did-
not clear.
Yeah.
Yeah, I
So in-
didn't take. I
In
didn't take
PDSA, it is
PDSA.
there. LRU. Okay.
No, sir, it is in operating system, I think.
Okay. Just 1 minute.
So would you please tell us that which portion we need to look into?
Yeah. This question.
Um,
Question number 14. What happened there? Question number 14, practice assignment. Okay. Yeah. Anyone solve this question? So here we are given one order, block order. Then there is system buffer with these three slots. Initially, the buffer is empty. If LRU buffer replacement policy is used, then how many misses will occur by referencing all the requested blocks. So what do you mean by misses here? Yes, anyone? Okay.
If the requested block is not there, that is a miss.
Yeah. So suppose there is a one buffer and having three slots. Okay. Buffer and having three slots. 1, 2, 3. Okay. And we have this order. Okay. Block references in given order. Okay. And the processor is demanding this block in particular order only. Right. Now what processor will do? It will call the block from the buffer and try to work on it. Right. Now if that block is not present in the buffer, then we can say it is a miss. And if that block number is present in the buffer, then we can say it is hit. Okay. There is two concepts, hit and miss. Okay. So let us discuss this question. Is my cursor is visible to everyone?
Yeah, cursor is
Yes,
visible.
yes.
Okay. So suppose there are three slots. Okay. S1, S2, S3, and the given order is 3, 4, 1, 4, 2, 3, 1. 1, 4, 2, 3. Okay, so what processor will do? First, it will find the block number 3 in the buffer. First, it is not there, right? So it will miss. We can say miss. So here we can add block number 3 because it is initially all the 3 slots are empty. Okay, then it will search for block number 4. Okay, so still it is a miss because block number 4 is not present. So still it is a miss, right? Then it will search for block number 1, 3, 4, 1, because block number 1 is not present here, right? 3 and 4 was present, so still it is a miss. Okay, now what about this block number 4? Okay, so first, what is LRU? Yes, anyone?
Least recent used block will be removed if.
Yes, least recently used, right? Now can I add block number 4 here, or block number 4 is already present here, right?
It is a hit.
Yeah, so since block number 4 is already present in the buffer, this is a hit, right? So we can simply repeat this 3, 4, 1, and this is hit, right? Now what about block number 2? Now processor is calling block number 2, but is it present in the buffer? No, right? So we need to remove one of the blocks. So which block we should remove? Then we have to follow this algorithm, that is least recently used. So among this, which is one least recently used?
3.
Yeah. Among these 3, 4, 1, which is least recently used 3, right? So we need to replace this 3 with 2. That is 2, 4, 1. Okay, this is also missed, right? Because block 2 was not present in the buffer. Now, similarly for block 3, block 3 is present in any of the slots? No, right? Then we need to remove this one of the block. Now, then which block we have to remove? Based on this LRU algorithm, this least recently used. So out of these 2, 4, 1, which one was least recently used? We need to check on the left hand side of this particular number. Okay, 2, 4, 1. So 1 is least recently used, right? So we need to replace this one with the 3, block number 3, 2, 4, and then 3, right?
Sir, but how is recently used?
So from this 2, 4, 1, which one is least recently used here? If I want to call the block number 3 here, 2 we just called, right? Before that 4, before that 1, right? This is the sequence.
Sir, this list is in terms of what? List in terms of integer or in
This
terms of
recently used
positions?
block, this number. We are talking about this particular block reference sequence, right?
Then we have been entered, we want to enter 2, we found 3 as a list. How this can?
Sorry, when we want to enter
2.
2, okay.
Then we remove 3 as a list. How this
Yeah,
is
because
happen?
least recently used means here if you traverse on the left hand side of 2 and 3, 4, 1, among these 3 was least recently used, okay, right?
Means which is entered first is going first. 3 is entered first, then it is a list and it will come out as first.
Yeah, so we have used block number 3, okay, before block number 4 and 1, right?
Yes.
Yeah, so that is least recently. So we have to remove that block. We have to enter that new block. It is block number 2 here.
Okay.
Yeah, but then 4 should be the least recently used. For the
For
third.
which case? For 3.
Yes, sir.
For 3, we have to find it 2, 4, 1. Now 2, 4, 1. So now least recently used is block number 1, right? Because we have inserted 1 here, right?
Because buffer size is 3 slots.
Yes, we have 3 slots, S1, S2,
Yes,
and S3.
yes. That's why we will want to go to 4 and we will check only 3 slots, 2, 4, and 1.
Yeah, when we want to call block number 3, we need to check this particular buffer, right? Slots S1, S2, S3. Here 2, 4, 1 is SN. Among these, which is one least recently used block number? Block number 1, right? Hello, are you getting it?
Yes.
Okay. Now, similarly, but I want to enter block number 1. Now, among these 2, 4, 3, which one is least recently used? If we traverse on the left side,
3.
3 just we have entered, right? 3, 2, 2, 4, 3.
4.
4.
4, yes, 3, 2, yes, 4, right? So we need to remove this block number 4 and enter 3, right? 2, 1, and 3. Okay. Now, what about this block number 4? Again, we need to add into slots, right? If we follow the same algorithm least recently used, then which block we have to remove from 2 and 3?
2.
because
Two.
2 least recent use just 2. Just instead of 2, just put block number 4, 1, 3. Then here also block number 2, which was least recently used 4, 1, 3, 3, right? Sorry,
3.
3, yes. So 4, 1, 2. Now we have to add block number 3. Then which one is least recently used? Block number 1, right? Yeah. So 4, 3, 2. So this all are missed because there, if we once the processor call this block number, was not present in the buffer. So that's why we have replaced that with another block number. So all are missed, right? The total number of misses will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 10, there will be 9 misses and 1 hit, right?
Sir, I have a doubt.
Hmm?
Sir, is that we have 3 slots in the question? We have to traverse only thrice. Is that like that?
No. In 3 slot, we are adding this block numbers, right? If it, yeah. So say suppose here we want to add 4, but 4 is not present in the buffer. So we need to remove one of the blocks. Now, which block we have to remove? For that, we are following this recently used algorithm, right? Then among these 2, 1, 3, which one is least recently used block number? Now just check on the left side of this particular block number. So among these 2, 1, 3, least recently used was block number 2, right? So that's why we have removed block number 2 and we have placed block number 4 here.
Sir, I would like to.
Hmm.
Can anyone tell in the LRU which data structure is used? Yeah, you know about the data structure, right?
Q.
Yeah, Q. So, sir, can you draw the particular 3 slot Q?
Which one? 214, right?
3 box.
Okay. Yes.
So can you tell me the property of the Q?
First in, first out, sir.
First in, first out. Suppose, sir, suppose this first one is the front. Yeah. First in, first out, right? So this first box is suppose the means front. There is 2 pointer, right? This is the front one. Sir, answer 3 box. Can you write that this is the front? One pointer is the front pointer, and the second one is the rear pointer.
Yeah.
This is the front pointer. And the back one is the rear pointer. So where is the least recent use is located, means where the data is there, which is the least recently used, front or rear?
Front.
Front is we are done insertion in the front side, right? Then the rear side is the, okay, you can assume that, and the front is the least recent use, and the rear side we insert the data, right?
Yes, sir.
So in the box, sir, can you?
Sir, then now 3 will be in the front and one will be in the rear point, sir.
Yeah. So which is in the first case, the first 3, 1.
Yeah.
3, 4, 1. So you can say that the 3 is the least recent use, right?
Yes, sir.
So how can you remove if there next time 2 is come, because the 4 is there already in the buffer box, right? Buffer, right? So when you want to insert this particular 2. So which should remove you? Which is got removed?
We remove 3
Yeah.
and
So
4 will go to the front. Is that right?
Yeah. Then your data is like in the buffer is the 412, right?
Yes, sir. Yeah.
Yeah. And next time when you want to insert 3, then which got removed?
4, sir.
4. Then your means 1, 2, 3, 4, right? Are you getting my point?
Yes, sir. 1, 2, 3.
1, 2, 3.
Sir, can you stop sharing? Okay. Can anyone tell what are the entry? So I think 4 is there.
The 3, 4, 1, 4,
3, 4, 1, 4,
2, 3,
2, 3,
1, 4, 2, 3.
1, 4, 2, 3. Right. So this is the queue. This is front and this is rear. So you already know about the queue data structure. The first in, first out. Right. So in first is used for removing the data and the rear is used for the adding the data. Right. You simply think about like this is the shop. Right. Right. Here people are making queue. So first 3 will come. Right. So 3 will come. So this is, you can say this is as the miss, right? So 1 miss is there. So next time 4 will come, right? So 2 miss is there. So next time 3, 4, 1. So 3 miss is there. So next time 4 will come. So in the buffer 4 will be there or not? 4 is there. So this is not miss, right? This is heat. So heat is 1, right? So next time if you want to insert, so in the next entry you got 4, 1, 2, right? So this is also a miss. You are getting my point, right?
Yes, sir.
Yeah. And the next time 3 is not in the buffer. So you can say the 5 misses occur. 1, 2, 3. And the next time 1. So 1 is already in the buffer. So this is 1 miss hit, right? So next you can see. So 1 is hit, right? And the next time the 4. So here is 1, 2, 3. Right? So here you get 2, 3, 4. That is miss. After if you 2 is there and the 3 is also there. Sir, is 6 misses there? Yep. Hello. Am I audible, right? Hello.
Yes, Pradeep,
Yes,
you
sir,
are
you are
audible.
audible.
Yeah.
Does anyone have any doubt now in this concept?
Sir, but we got 9 initially and now it is 6. So what is the difference happen now?
Initially, the block, the buffer is empty, right? So that way, that 3 misses also we have to consider, Pradeep, right?
Okay. Okay.
That is also missed, right? I have, I think this is clear to everyone. When you are using the LRU, then we using the queue, right? And when we use the first, I think the first in last out, right? Here we using the stack, right? So I hope it is clear to everyone.
Sir, for what we are using stack, can you repeat?
Here, suppose like this, here it is mentioned that we have to use the LRU algorithm, right? So there it is mentioned that this means FI, I think first come first serve is queue and the first come last out, right? In the stack you seen that in the stack, the first come last out, right? Or you can see say that's the last in first out, that is stack, right?
Yes, sir.
Yeah.
Sir, I am actually asking like for least recently used, we are using queue. Then for which we are going to use stack? That's my question.
Yeah, I am telling that question. In that question, explicitly it is mentioned that the first in, first out algorithm is used. So in the question, it is given in the place of the LRU, it is given that first in, first out, right? First in, last out. So it is mentioned. Then you have to use the stack.
Okay, sir. Okay, I got it.
Yep, you can carry.
Yes, sir. Any other doubt? Any other question? So I hope you all have solved the SQL practice question. Tomorrow we are going to release the solution for that. Yes, anyone? Any doubt in activity or practice question? Okay. Mhm. How many of you have solved all the 30 SQL practice questions that we have released? Can you please raise your hand? No one. Okay, no problem. Okay, great. 25 questions. Yeah. Okay, any doubt in week 7 content, activity question, practice question? Or else we can take few SQL questions also. We can discuss that. Okay. Yeah. Anjana, do you have any questions on peer deck?
Yes, sir.
Okay, yeah. So we'll be taking few questions based on like SQL practice questions only. Okay.
Share the link.
Yeah.
You all can click on the link that I've shared on the chat box. Okay, 8 students have joined. Hello. I hope all of you are able to go through the link and join. Only 10 students. Okay, only 12 students I can see. You all can click on the link that I've shared on the chat.
I think we can start. They can join later.
Okay.
Yeah.
Okay, so the first question is from the LIS database. So it says write an SQL query to find out the total number of members in the UG with LIS name or column header as total member. So you need to find out the total number of members in the UG and with an LIS name or column header as total member. So you all can give your responses. We'll wait for some time. Only 6 responses. Okay, we'll wait for 1 or 2 minutes. Only 6 responses out of 13. The question is clear, right? Okay, we'll wait for a minute and then we'll head to the responses. Yes, Nihal, you'll have to look up the LIS schema. So, yeah. Sir, shall we head to the responses then?
Yes.
Okay. So,
Select roll number. Okay. Department code is UT. Okay. Yeah. So yeah, this one is correct. We select count number as total underscore member. Count members, so member type equals to UT. Yeah, this is also correct. Total. Total. Okay, someone is using a double code for the LIS, right? So when to use double code and when not to use? Is anyone? Or every time we have to use double code only?
When specifying the alias or attribute name, and when accessing the particular value of a tuple, we use single quotes.
Okay, so what if I didn't use double quote here for aliasing the column name?
Where, sir?
What if I didn't use a double quote here? Is it necessary to use here? You can see two queries are there. Okay. Yes. Both the query will use same output and it will rename as total underscore member also, right? Even if you didn't use the double quotation.
So single quotes is giving me an error.
Yeah, single quote will give an error.
Yeah, sir. So either we use double quotes or no quotes, right?
Okay, just necessary to use quotes here. Chandra, can you stop sharing 1 minute here?
Yes, sir.
Let us discuss that thing. Okay, so is my screen is visible? See here, I am using the select count member type as total underscore member. Okay, so I'm not using any double quote here, but still I'm getting total underscore member. So what if I didn't do this underscore? Then in that case, it will throw an error, right? Now, what if I want this column name as total space member? And in that case, I have to use double quote. See here, space is there, right? If you didn't use the double quotation here, it will throw an error. And one more thing, if I didn't use this double quotation and just type total underscore member, T and M are capital here. Okay. Now let's see what happens. It will take the lowercase of T and M. And what if I want this T as capital and this M as both T and M as capital? So now we have to use double quotation here. Now let's try to run this. See here you can see. Okay. Now when to use double quote? See, if you want to have space in between the rename, you can use double quotation or any capitalizing what you need, then you can use the double quote. Otherwise, you can omit that. Okay. It will give in a small letter, right? Lowercase. Yes, anyone?
Yes, sir, it is just to keep the format that we required, right?
Right, yes. So suppose in question we have mentioned total T capital space then member M capital, then in that case you have to use double quote. Right, total space member. Okay. So this is a small difference between when to use this double quote and not to use. Okay. Yeah. You can try this out. Yes, and then we can go on to next question.
Okay, so the next question is also from LIS database. It says write an SQL query to find out the number of female students in each department. So you'll have to find out total number of female students from each particular department. So we'll wait for some time. Okay, only 4 responses till now. If anybody is facing any doubt in this question, you can ask. Only 4 responses yet. Okay, so I think that we can head to the responses.
Yes.
Yes.
So why do we need departments table here? Who wrote this query? Realized it.
So because in the table we're grouping by department, haven't completed it.
If we need the department name rather than the department code, then we have to use departments. I tried with department code also.
Yeah, so we have to find out number of famous words in each department. Yeah. So if it is mentioned department name, then we have to use department table, or for department code, we can use student table only, right? Mhm. Okay. Yeah. Department code. Roll number. Mhm. Mhm. Department code. Okay, great. Most of you got correct, right? Mhm. Okay. Department. Okay, this is also correct, right? Gender. Okay, any doubt in this question? Anyone? Okay, so we can go to the next question.
Okay, so the next question is from the FLIS database. So it says write an SQL query to find the names and date of birth of those managers who have joined in years 2019 and 2020. So accordingly, you'll have to find out the names and date of birth of those managers. So again, we'll wait for some time for your responses.
Yeah, just see the schema, okay? FLIS schema. By looking at the schema, you should be able to formulate the query. So we have managers table in FLIS. In that manager ID, name, date of birth, team underscore ID, and since. Since is the attribute having data type date. So when we say that we have joined in years 2019 and 2020, then what date we have to use?
We have 3 responses out of 15.
Yes, we can see the responses. Date of birth. Extract year from since. Okay. What is the question? And
So to
2019.
find out who has joined in years 2019 and 2020.
So or is the correct here?
No, sir. It is said that the managers who have joined in years 2019 and 2020 both.
Yes, who wrote this query? Yes, anyone can explain. Yes.
Sir.
Yes.
Because if we take only from both the years, then it will be null. No records will be there. So.
And is this the correct way? Do we get required result?
If we want from 2019 and to 2020, then I think it is. Because if we use in also, then it will also be fetching from 2020 and 2019 and not both from both. Because no manager has a joining date as 2020 and 2019 both.
No manager has. Okay. All right. Can you scroll up, Anjana? 1 minute. Okay. Yes, scroll down. Union select staff manager.
This is wrong, right? Sir?
No. Since between
Okay,
between operator is there. Yeah.
Yeah.
2000. Yeah. Yes, that will work. Yeah. Select not star form because we need to find out name and date of birth only, right? So we are since between 1931 union manager between. Okay. Yeah. Yes, union. Okay, so while using the set operations, please make sure if there is any duplicate value, it will not return those duplicate values, right? Say suppose like we have the same manager name, like who had join in within those period, so it will not repeat that particular name, right? Because set operation will not give the unique value, right?
Yeah, sir. So I need to substitute it with union all,
Union
right?
all, right? Yeah.
Okay.
Then okay. Here from since or extract here from since. Okay. Yeah, fine. Okay.
So sir, we'll head to the next question.
We can go to next question.
Okay, so again, this question is from FLIS. It says write an SQL query to find the names of players that start with S but does not end with N. So we'll wait for some time for your responses.
Okay, and then I think we can see the response. Select name from players and like this. Okay. Why intersect here? Yes, anyone?
Sorry, sir.
So why do we need intersect operation here? We need to find out the like a name of a student whose name start with S but does not end with N.
So here it is not like.
Okay, not like N. But still it will not give the correct result, right? Yes, anyone can explain this query? Who wrote this query? Okay, so let's start from where name. Make this person accept. Okay.
We only need to find out the name. So star is not really required.
Yeah, ma'am. Got it.
Yeah.
Select name from where. Yeah, this is also okay. Okay. Yeah. Your name, not right. S percent in the question where make capital S or small s?
Capital S. Sir.
Capital S, right?
So this is not required.
Okay.
Yes, most of them have got it right.
Okay, great. Okay, Anjana, yeah.
Yeah.
Yeah, so one more thing. Yes, Pradeep.
Yeah, I would like to mention one thing that what we previously discussed on the practice question 14, that we discussed about the first in, first out means algorithm.
I'm getting value.
Yeah. That we already discussed in the live session, that is the
Better to override.
Yeah. That is the first in, first out. Yeah. And for the LRU, this is we replaced with which is the least recently used. So how to solve this particular question? So first write 3, 4, 1, 4, 2, 3, and we replace with that value which is least recently used. Okay. So there is 3 place, right? So first place we get the 3, that is miss, right? And the second place we get 3, 4, that is also miss, and after that we get 3, 4, 1. Okay. Now 1, that is not required. You can same thing write as 3, 4, 1, 4, 3. Right. So after 4 will come, you can see this is in the buffer, right? So this is heat. So 1, 4, 3. And the 2 is not in the buffer. So how to replace this particular value? So you have to check which value is least recently used. So how to check? Here you can check. 4 is recently used, and the 1 is also recently used. So we replace with this 3 value, right? So that is 1, 4, 2. So that is miss also. After that, you get the 3. 3 is not in the buffer also. So we have to replace with the least recently used, which is 2 is recently used and the 4 is recently used. But 1 is the, so we replace with this particular one. Right. So that is also missed. And now 1 is not in the buffer. So we have to replace 1 with, so we have to check which is least recently used, that is 4. Right. So that is also missed. Are you able to follow me, right? So here you can see 4 is not in the buffer. So how to replace, which value is replaced 4? So you have to check 1 is recently used, 3 is the 2. So that is 1, 4. That is also missed. So now again, so for the 2, so 2 is not in the buffer. How to replace with this 1, 2, 3? So 3. 3 is replaced with 2 and that. Now 3 is not in the buffer. So how to replace with that? So with 1 you get. So you can see miss is 9 and 8 is 1. But I hope it is clear to everyone how to use the which is least recently used.
The same thing I have also explained that. Yeah. So after that we explain based on FIFO, right?
What we have explained previously, that is the FIFO. So any other
anyone
doubt?
any confusion in this? Any doubt?
Any question regarding 8.4 week 8 activity practice? Yes, sir. Thank you.
Yeah. So please go through the practice assignment questions. If you have any doubt, you can ask the next question also. Okay. Yeah. Any doubt? Week 7. Okay. Okay. Thank you then. You can wind up this session.
Okay. Thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.